Okay, let's start to discuss about our first quiz in database system. Question number 1. Given the relations studinfo and enroll, assume that every course is taken by at least one male and at least one female student. What does the following relational algebra expression represent? So if we see something like this, array expressions, we need to solve something in the most inner part. So I guess this one. Okay, I see studinfo, this one, but I just want to select everything that is female. And then what next is this one. Okay, I just want to show the student ID only, right? I don't want to get the name or the sex as well. The next step is I want to cross them, this is not join, cross with everything I have in the enroll relation. I want to cross the student ID with course ID in the enroll. That means I pair them up, every single record in here, I pair them up with every single record in these relations. Okay. Next, I want to subtract, minus with this one, enroll, which has the course ID equals to 1. Minus, that's mean everything but not course ID equals to 1. Okay, and then the last part is I just want to get the course ID only. Right, so let's check the options. Courses in which all the male students are enrolled. No, of course, because I select them with female in here. All courses other than ID equals to 1 and stud ID exists in studinfo. No, because this expression doesn't say anything about female student. But in here I have female. All female student with course ID equals to 1. Of course not, because I already exclude them in the result. So I guess the last part is correct. Courses in which all the female students are enrolled except with ID 1. So this is the correct answers. Okay, next questions. If we want to show employee who get higher salary than anyone in the department 5, which one of the statement is true? Okay, so if we see how many people in the department 5, we have 2 people, employee ID 1 and employee ID 5. But I just want to get anyone, show all the employee who get higher salary than anyone in the department 5. So it can be this guy, but not this guy, and this one. This is including. Why? Because 50 is not higher than 100, but 200 is higher, 300 is higher, 300 also higher than 100. So any meaning that only single person can satisfy the query. Okay, let's check. Query number 1, select employee ID from employee table E. This is a prefix where not exist. Select all from employee table S, where S.department equals to 5 and S, this one, salary greater than equals to salary. Okay, query number 2, select employee ID from employee table where salary greater than any. Select distinct salary from employee table S where S.department equals to 5. So, the same, in MySQL, in SQL language, you can also use any. That's mean you get only one. Anyone that can satisfy the conditions. So select distinct salary. That's mean you can only return the salary that is different from the other person, the other salary, from employee table where S.department equals. Okay, so we solve this part first. S.department equals to 5, select distinct, that's mean you will return 100 and this one, right, and 300. And then you select employee ID from employee tables where salary greater than any. That means greater than 100. So this query will return 2, 3, and 5. So the answer is query number 2. Question number 3. Which of the following statements are true about SQL query? Okay, first, an SQL query can contain a having clause even if it does not have a group by. That's correct, yeah, entirely correct. You can try this in MySQL language. You don't have to have this one group by. You can just saying having, because this one is for grouping the aggregate functions, and this one is just for limiting the result of aggregation function. Okay, all attributes used in the group by must appear in the select clause. No, this is not correct, because if you put the group by employee ID, for example, and you don't want to show it, that's fine. So this is not correct. An SQL query can contain a having clause only if it has a group by clause. Yeah, the same like this one. An SQL query can contain having only if this one, even if it does not. So this is quite similar. So this is incorrect. Yeah, only if. So but the actual answer is, yeah, you can have having without having the group by clause. So this is incorrect. Okay, option number 4. Not all the attribute used in select clause needs to be appeared in group by clause except for the primary key. This is correct, yeah. So these two are correct. Why? You can try, yeah, in SQL. Unless you mentioning you want to show the primary key of that table, you need to mention in the group by. But it's like name, for example. Name is not your primary key. You can still select them in the select clause, but you cannot select the employee ID, for example, without using the group by employee ID. Okay, number 4. Okay, so this is very, very easy. The attribute set of a relationship is represented in the ER diagram as not the double diamond, rectangle connected with the dashed line. This is correct, yeah, because we're asking about the attribute sets of a relationships. Yeah, it's like this. And then you have like this, right? So this is your entity. This is your entity with attributes. This is your relationships. So if you have attribute, you can show it like this, or you can show it like this. Yeah, it can be like this or like this. So this one is correct answers. Not this one, ellipse connected to rectangle means attribute of entity. This one. A rectangle with solid line connected to an ellipse. So basically these two is the same. So they're both incorrect. Question number 5. Functional dependency for relations are given below. Based on the functional dependency given above, which statements are true? Select all that apply. Okay, let's check. We know that this is primary key, D, E, G. D, E, G, H, F, A, V. Okay? Okay, let's check from the first options. FD5 shows the partial dependency. FD5, we know that partial dependency is part of the primary key that explain something else. So we know that DEG is the primary key. Of course, part of this can be D, can be E, DE, or EG, or DG. These are all partial key. So this is called partial. This is correct. Yeah, because it's belong to the primary key. FD2 shows the transitive dependency. Let's check. FD2, A explain C. Okay, A explain C. Okay, how about yes, this is correct. Yeah, because from this one you know another attributes, and this one is not the primary key, so this is correct. FD1 shows the partial dependency. FD1 B, this is B, this is not the key, this is B, this is not the key as well, so that's mean no, this is not correct. That's mean this is only the transitive dependency, not partial. C is the foreign key, is not clear. Yeah, C is the foreign key. No, this is not foreign key. C never appear as the key at all, so this is not correct. So this is only two options. Question number 6. Okay, given the relations with the dependencies as below, the relation R contain 150 tuples and relation S contain 50 tuples. What is the maximum number of tuples possible in the natural joins? Natural, remember natural. They always join whatever they think it's good for joining those two tables. So let's check. B explain A explain C. Yeah, if you know B, and then you will know A, and then A, you know C. Okay, from here, B, you know A, you know C. This one as well, B, and then, yes, you know A, and you know C. That's mean it looks like B is the key, right? Okay, you know the key, and then when you join them together, this is 150 with the same record. Yeah, this is 50. So when you joining them together using natural join, yeah, which is on key B, that's mean the maximum number of tuple you can get is the smallest number, this one. Why? Because in here is only 50. You cannot get more than 50 because this is already represent B. Yeah, in here. You cannot get more than B. That appear in the S because you need to match, right? Match the key. Question number 7. The relationship R has functional dependency as follows. Okay, this is similar like question number 5, I guess. Which ones of the following statements are true? There is a transitive dependency occurs. Let's check. This is primary key F, G. And then G is this is part of the primary key. That's mean this is the partial. Okay, this one is easy. So to satisfy 2 and F, we need to remove FD2. This is correct. Let's check if there is a transitive dependency. FG can decide the value of DE, H, A, B, C. So let's check FD4. B and D can determine the value of H. That means this is transitive. Let's check FD1. A and C can determine the value of B and D. So this is also transitive. This is partial. Okay. There is a transitive, of course, yes. We have 2 in here. There is no partial, no. This is not correct because we already have this one, yeah. FD2. To satisfy 3 and F, we need to remove FD1. That's correct. Because FD1 is the transitive. Question number 8. Given the ERD of a library. Okay, let's check. ISBN and book title are the primary keys. ISBN with the underline, this is correct, it's primary key. How about the title? No, this is not the primary key. Why? Because there is no underline. It's supposed to be ISBN and member ID, right? So this is not correct. A member can borrow more than one book. This is also not correct. Look at this. Member borrow 0 or 1, right? So being a member can borrow 0 book or at least 1. So this is not correct, yeah, because this is the cardinality is only 1. Available book can be found in the database. What does it mean? Book borrowed by a member. Okay. So book can be borrowed by 0 member or more than 1 member, right? So 3 member can borrow 1 book. Available book can be found in the database. Yes, that's mean no one borrowed this book. So this is correct, yeah? Because this is 0 in here. Can be borrowed by 0 member. That's mean you can still browse in the library. Date and duration are the entities. Of course, it's not correct. Date and durations is not entity because the symbol is ellipse. Ellipse is for attributes. Date and duration can only be filled when there is a borrowing transactions. Yeah, you cannot fill this if you don't have this borrow transaction. So this is correct. Next question, number 9. Okay. All the primary keys contain numeric only data type in the given relations. Which one of the correct tuple relational calculus for the following queries? What are the IDs of the CS student taking discrete structures? Okay, let's check. First options. I want to show the IDs. So, yeah, this is correct. STD ID. Yeah. ID of the students with the conditions given. Student S, yeah, and course C, department D. Okay, let's check. I have student table, course table, and department table. Okay, and then I start joining them up. S.major.id, S.major.id, this one, I want to join this with C, major ID, my first key. Okay, these two guys already joined. And then, what the second key? Major ID from S with the major ID from D. So this one with this one. Okay, so these two tables already joined. Okay, yeah? This one and this one. Alright, so we good with the joining table. And then what next? D dot D name. So this one equals to CS. Okay, this is correct because I want the CS student that come from the CS department. And C name, the course name, equals to discrete structure because I want them. I want all the record that taking the discrete structures. So this is correct, yeah, straightforward. You need to know which table that you need to join, and then you join them together, and then that's it. You just want to show what things that you need to be in your result. This is CS student, that's mean the department is CS, and then the course is discrete structures. How about the second options? Student, course, and enroll. Student, course, and enroll. They both, the three of them have the major ID, but in enroll you cannot get the D name. Yeah, there is no CS department. So this is not correct. Student, department, enroll. No, because in enroll you cannot see the course name. Option number 4, student, course, department, and enroll. So this is joining everything. Okay, why not this one? S.major ID, D.major ID, S.std ID e.student ID. So you're joining S and E by their student ID, and then you're joining major ID from S, this one, with the D major ID, this one. Okay, no one joining the course, so course is not joined with this whole join statement. So yeah, this is wrong, yeah, because the C name is in here. So if you want to join them together, you miss one key in here. You still can use this 4 table together, but you still need to put the key of major ID, at least connect it with this student. Otherwise they will, yeah, float somewhere and no one hold this. Okay, next, last question is easy. In a relations, columns are sometimes called, what is a column? It can be attributes or fields. Yeah, not tuple. Tuple and record is the same. This is means row. Entities is something else, yeah, conceptual thing when you're designing the ERD. And this one talking about relations. Okay, that's it. Thank you very much. We see you again in the next quiz.